Okay, it's Mr. Rops.
And Mr. Cole.
And we are going to take you through your linear modeling task. So, and especially doing the technology and helping out with the math. So the first step, what we're going to do.
Okay, so first of all, number one, using Logger Pro to get a table of data that shows the motion of you walking towards the sensor. So we're going to do this in class. We're going to set up a graph of you walking away from a motion sensor, walking towards a motion sensor. Mr. Rops has done one with him walking away from the sensor, so his looks a bit different.
Right, and that's okay. So select a region that looks straight, and then we'll see what the values are. So right now I have 1.65 all the way to 3.9. So I'm going to select those values.
Oh, should we do the same ones, actually?
Yeah, we'll do the same ones though.
Yep.
Going up to 1.65. Okay, and I'm going to copy those, and I'm going to paste them into Excel. But I don't really want them in Excel. I'm going to copy them from Excel now, and I'm going to put them into GeoGebra. Oh, let me get a new window here in GeoGebra. So in GeoGebra, we're going to view the spreadsheet, and I'm going to put it on this cell, and I'm going to just paste them. Command V. And those are all my values. This is time, and this is position. All right, and so what I want to do next, what's the next step we're going to do?
Okay, so next we need to make an equation of the line from any 2 points that are in our data set. So we're going to choose 2 points that are quite far apart.
Right.
Mr. Robbs just selected the first point.
Right, which is 1.7 and comma 1.56.
So that's our x1, y1. That's the first coordinate. And then our second coordinate is selecting another one.
Right, 3.7.
Okay, it doesn't matter which ones you choose, as long as you get them nice and far apart.
Right. So here's 1.7, here's 3.7, so it's right far across the graphs. So I take those points, and let's...
Okay, so that point there will be x2 and y2, our second coordinate.
x2, y2, x1, y1.
Okay, so first up we need the gradient formula. We need to know the steepness of the line between those 2 points.
Right, so I'm going to go y2 minus y1 over x2 minus x1.
Okay.
Plugging my values in.
So we've got 2.61832. We're going to skip with just, we've got 5 decimal places there. I think that's more than enough. And then 56271. Okay.
Divide it by...
So 3.7 minus 1.7.
And so when we do this calculation, we end up with 0.528 or 781.
Oh.
2781.
Okay. Of course, you're going to end up with a different number.
All right. Your number will be different, and that's okay because we have a different set of data, and I'm even walking away from the sensor where you were walking towards the sensor, so it'll look different. Now we have to find the equation. We use our lovely formula, y minus y1 equals mx minus x1. Plug in our values. We know y1 is the 1.56.
So let's do
271.
One.
Oh, this one here.
There, sorry. Keep up with you.
0.52781.
Yep.
X minus the 1.7.
Good. All right. We need to expand those brackets first.
All right. 6271 equal to 0.52781.
So times the x, and then times that by negative 1.7, and we get negative 0.89727. All right, now we need to move that, get y on its own.
All right, so y then equals 0.52781x.
Add 0.66544. So we added that 1.56271 to both sides.
Right. This is our line of best fit. Line of best fit. All right, great. Now, next step in our task sheet, what's it say to do?
Oh, let's find it again. So then using GeoGebra, graph this line.
Okay, so what I need to do though is I need to plot all these points. And so if I take these points, select them all, go down, select these points, and what I'm going to, let me try that again. If I then go, and if I select the points.
Okay, so we're trying to plot all these points on our axes that are on the left there.
Okay, and if I go to this icon here, and I'm going to say, hold this icon down, and I'm going to make a list, create list of points. I'm going to create them, and here are all my points, really tucked in there really well. And so if I drag off my equation somewhere, and then I can expand my axis a little bit. All right.
Oh, there we go.
There we go. Make it out a little bit further, and then I'll drag my. And let's pull this axis up here. And I want to go up. Let's see what we get. We can start to see our graph here. And so we can play around a little bit about our settings of our windows to see our scenario here. Let's bring it in just a little bit. All right. So here is our line. There. Okay, so now what I want to do is I want to come along and I'm going to go to the pointer and I'm going to select all those points. And then go over to this icon here. And if, I lost my selection. So I'm going to go to this, select all my points.
Okay. Do we need to? Sorry, Mr. Rubbs. Do we need to put the line that we got in first?
Oh, is that what it says to do?
Yeah. So number 4 on the steps is put the line that we found into GeoGebra, and then we're gonna. What Mr. Rubbs is doing now is getting GeoGebra to make another line of best fit.
All right. So 0.52781 space x. And it's really tricky with spaces and stuff, so put spaces between everything. Plus 0.66544. I hit enter, and there is my graph. If I look at here, if I spread my points out a bit.
Yeah, we can see we did a pretty good line of best fit there.
Right, it fits quite nicely.
But what the point of this, the task is to see if we can see if we do it as well as the computer. So the computer's also going to generate a line of best fit.
And let's take this and let's see if we can change the color of that so we know we're going to make that one red. All right, so that line is red. So now let's go and select all the points. And I'm going to go to this one, click on that little tiny arrow, and I'm going to make the line of best fit. The black one that just made is the computer's version. Now I want to view the algebra side here. And so this is the red line that we made, and I'm going to select it and change the decimal option to rounding to make 5 decimal places. We can see it there. And now, my line of best fit that I just created with GeoGebra is way down here. And if I double click on it and do object properties, algebra, I can change it to y equals mx plus b form, and better. I see it there.
So let's write that one down. What have we got? We've got
0.52743 x plus 0.6693.
Okay, good. And you might need to zoom in a little bit on your graph or change the scales just to see that they are 2 different lines.
Right.
You can see them quite nicely on this one, I think.
Okay, I think so too. And then we can expand this out here if we want to see, get the axis, there we go. And then you can see that they're close, but they're not exactly the same. You can see how ours is off just a little bit.
Yeah, ours looks way off.
It is. Oh, there is something wrong. They should be really close. I shouldn't be quite so far away. Let's look at my equation. Oh, here it is. I typed in something wrong here. So we got to fix that. I don't know where that number came from.
What should that be? We should have add 0.66544.
544. Enter. There we go. Now, if we zoom in a little bit, we should probably be able to see that line. We can vaguely see that there is...
Oh, there is actually two lines there.
Right? You can see the red and black there. If you look really carefully, you can see that there's two. Okay, that means we've done a pretty good job, I would think, with our estimating.
That means our estimate and the one that the computer did are very close together.
Right. Okay, so now which step are we on? Like from our task.
Let me look. So I think we've got two. Right, we just need to compare the two graphs visually and discuss. So we've kind of done that a little bit.
And when we visualize and compare them, compare the slope and the y-intercept, you should have a conversation about those both.
Yeah, I think you need to have that in your, the actual graph that you're talking about there in your write-up.
Agreed.
To be discussing. And then use the GeoGebra spreadsheets, compare the two graphs numerically. Right, so how are we going to do that?
Okay, so what we're going to do is I'm going to use GeoGebra to actually predict what all these values should be. So I'm going to go equal to, my equation line is 0.52781 space, there's my x value, which is my A2. Actually, I'm going to make this a multiplication sign, just to make sure it knows I'm multiplying. And then I'm going to add 0.66544. That is my equation line, and I hit enter. And so the actual value should be, by predicting from my line, should be this. The real value is this one, so they're really close. And I'm going to take that, and I'm going to do it for all my things. By taking that corner and dragging it down, I can do the computation all at one time.
Okay, so those are all the positions found using your equation.
Right. And so now one thing I can do to see if if I want to find how close they are from the actual value, I can find the difference between them. To do that, I go equal. I'm going to take the real value, position, and I'm going to subtract my predicted value. Okay? Actually, sorry, I should do it the other way around. I should do my predicted value minus the line value. And if I do that, if I drag it down, I can do all the values here. Okay? And you'll notice some are positive, some are negative. You might want to have in your write-up what's the difference between the positives and the negatives. Now, if I want to see if it's how well it is, I could take these values and I'm going to actually take the difference and I'm going to square them to make them all positive squared. So I go equal this value to the power of 2. Enter. And I'm going to drag this all down and see what we get. We get all those values. Some are really, really close. And then what I want to do is I want to add them up, equal to the sum of this list here. Ooh. It's stuck. Let's see if I can.
Does it do it automatically?
Let's try and see. Sum.
So we want sum of the sum squared errors. Is that right?
Let's just, if I go to here, I can select this list. Oh, come back. I think I can do that. Hit enter. Doesn't like that command.
I think there was other stuff in there first.
Ah, I want E2 to E47. There we go. Okay, so I want E2 to E47. And this is the sum of all my errors squared.
Okay.
Okay? So that's telling me that I'm really, really close to the line of to the line, or to the points. My line that we made with y equals mx plus b is close to the actual coordinate points. Let's also do the same kind of analysis with the computer line. So the GeoGebra line, GGB line. Okay, let's do GGB line. And so I'm going to take this scenario. Its equation of the line is down here. 0.52743x. So it's 0.52743 times my x value is my time.
Yep.
And then plus
0.6693.
0.6693.
Okay.
Right, because we wrote that down from before. There we go. And I get this, drag it down, and it will. So all these points that we just calculated here are what GeoGebra line of best fit are the values for them. We are comparing them to the actual position is what we need to do, compare how those two are doing together. To do that, we'll do the difference again.
So we're always comparing the line, whether it's our line or GeoGebra's line, with the actual coordinates that we got off LoggerPro.
C2 minus B2. So
what do we need? G2 minus B2. No, F2 minus B2.
F2 minus B2.
The real position. Yep.
Okay. Drag this down. Love this command on Excel or spreadsheets. And that's all the values. Then I want to find
Need to square them again.
square them. Diff squared, which is equal to this to the power of 2. Drag it down.
Okay, and we're going to see if the sum of all of those squared errors is bigger or smaller than the sum of all the errors from our line of best fit.
Right, so we're going to go from, this is H2 to H47. Let's see.
Should work. Too many brackets.
Too many brackets.
Yeah, just click it first.
Try that.
There
we go. So this is the sum of the errors for GeoGebra's line. This is the sum of the errors of my line. Because there is more error on my line, the GeoGebra one is better.
Very similar.
They're very similar. Okay, there's a numerical analysis. What steps were that we just did?
So that was number 7, compare the two graphs numerically. All right, and then what's left to do after that? We need to choose the best model, so explain which model is the best.
Right, based upon this calculation you just did.
Yep. And then using the best model, predict the location when the time is 50 seconds. That's step 9.
Okay, so step 9. So now, once we have our best model, which is the GeoGebra model, which
in our case it was the GeoGebra model.
Right.
In your one, it might not be actually. You might find that your the one that you did might actually work out better. We'll
right.
see.
It does happen sometimes. Plus 0.6693. This was from GeoGebra.
So we've chosen our best model to predict, and we want to predict the location when the time is 50 seconds.
Right. So as opposed to y, I'm going to change it rather to, this is, let's say, position. I'll call it p. And x will be time, t, let's say. And so we want to find when the position is 50.
We want to find when the time is 50.
So when the time is 50, you want to find p. That is step number 8.
That's step number 9.
Number 9.
And then do you want to actually do it, or should we
No,
just...
I'm going to let them do that. I think
that's enough of it.
Yep.
Enough help. And then number 10, predict the best use the best model, so the same one again, to predict what time it will be when you are 3 meters away.
And P equals 3 meters.
So a little bit of algebra to do there to work out what time that will be.
Okay.
And then we need to do the write-up and make sense of those answers.
Right. And so when you're doing this write-up, you have to think about that time is seconds, and P is your position away from the monitor, the motion detector.
Do you want to go through this stuff? Or do you want to, or can they read that? What do you think?
I think they can probably read it. Some of the things I think we might want to make sure that they're aware of, though, is make sure you justify your choice by looking for the best model, by using those sum of squares. Discuss what the slope means in the context of this task. So here's the slope. Here's the slope. What does this slope mean in the context of me walking towards the sensor? Now be careful, my slope will be different than your slope. Because we were walking away from the sensor. You're walking towards the sensor.
Okay, so particularly any negative signs, positive signs, you just need to put as much explanation as you can in there. This is being graded for criteria C, which is how well you communicate your maths.
Right.
And then criteria D, how can you show that you understand we're looking at accuracy.
Right.
So it's a reflection on how accurate our methods are and showing that you understand what we've done.
Right, and all with the context of what our scenario is. We're also going to talk about the y-intercept. Make sure we look at the y-intercept, what it means in the context of this problem. And then practical versus physical limitations. The practical limitations are like you were in a classroom walking towards a sensor. What are limitations to that? The theoretical limitations are if we pretend we're not in a classroom, we have all the space in the world. In theory, what do these numbers mean? That would be number 11 on the write-up. Number 12, we've done the calculations, then write a conclusion. This task must be submitted 3 different ways. One to turnitin.com, you must email a copy to your teacher, and then you must also give a hard copy to your teacher. Is there anything else we need to add there, Mr. Cole?
No, I think it's covered. Just there is a page limit on this. It's 5 pages. All right, so it does take a little bit. You have to be quite concise with your explaining. We don't want to repeat the same point lots of times. We just want to be really clear, really concise, and make sure you explain each step and what everything means in real life.
Right. And so you're going to be cutting and pasting a lot of these tables and graphs into your document. The math should be typed with math type or using Microsoft Word's equation editor. The table, the original data table that you can get from Excel is really long. You might want to put into several columns, or this table I would be okay with being put on as an appendix at the end.
Yeah, I think I'd be okay with that as well. Okay. Yeah.
Good luck.
Yeah, enjoy.